going to look at solving equations involving surds. So here the question says solve the equation. This is the equation. Now let's start solving this. So we can start by writing it. This is 2 plus 3 minus root of x plus 1 is equals to x minus 2. So we are going to start by saying squaring both sides. So we're going to square both sides. So we're going to square this is 2x plus 3 minus x plus 1. Then this so we square this. We're also going to square root of x minus 2. We square this side. Now I want us to remember here what we said: a minus b squared is equals to a squared minus 2ab plus b squared. So here this is what we have. This is a, this is b. So instead of having to expand this thing, it's going to take up a lot of space and it's going to create a lot of room for error. But if you just do it like this, it makes the process shorter and also it minimizes error. So here what do we have? We have a squared, so this is 2x plus 3 squared minus 2ab, and here we're going to multiply. So in bracket we'll have 2x plus 3 into x plus 1 minus this, this is a plus squared. It's going to be equals here, this and this cancel, this is going to be equals to x minus 2. So you can now say consider 2x plus 3 so that we can expand it faster. This is going to be 2x into x plus 1 plus 3 into x plus 1. So what do we have? We have 2x squared plus 2x plus 3x plus 3. So here we end up having, this is 2x squared. This is going to be 2x squared plus 5x plus 3. So we have this. Now we are going to bring it here. But now here, remember, this goes with this. What do we have? We have 2x plus 3 minus 2 into 2x squared plus 5x plus 3 plus this and this cancels plus x plus 1 is equals to x minus 2. So we factorize, we like collect like terms here very fast. So we're going to say 2x plus x, we get 3x, then 3. This is 2x, yes, plus x, we get 3x, then we get 3 plus 1, so this is plus 4 minus 2 into 2x squared plus 5x plus 3 is equals to x minus 2. So we're going to bring this side and we take this big term that side. So what are we going to have? You're going to have 3x, this, when this comes this side, this becomes 2x, because when this comes this side, this will be 3 minus 1, so this will be 2x, then this was 4, so this becomes plus 6, becomes equals to 2 into 2x squared plus 5x plus 3. So here we can divide through by 2. So we divide through by 2, we get x plus 3 is equals to root of 2x squared plus 5x plus 3. Then we are going to say squaring both sides. Then we end up having x plus 3 squared is equals to this root of 2x squared plus 5x plus 3, and we also square this. So this will go with this. But now here, we're going to just compare a plus b squared. So we're just going to compare this. So we have x squared plus 2 times this times this. So this is 6x plus 9 is equals to 2x squared plus 5x plus 3. So usually what makes these numbers somehow difficult to solve is just how you work with these values. Usually people make errors. So when we have this, we're going to take this side. So we'll have x squared, so because this is 2x minus x, plus this is 5 minus 6, so we'll have negative 6, then this is plus 3, then minus 9, I'll have minus 6 is equals to 0. So now because of limited space, I can't I can't show how I'm solving this quadratic equation, but I'm going to, if I use factorization method, I'll end up having x plus 2 and then x minus 3 is equals to 0. So x is -2 or x is 3. But you can solve this quadratic equation using any method of your choice. So when I have this, I have to verify, because not both of these can solve this. So I have to verify the answer. So now I have to come and say, though because of space it may not be possible to verify both. So I can come and say when x is equals to -2, for example, then I come and say left hand side. So the left hand side is this side. The left hand side is 2x plus 3 minus this. So now I come and substitute. So I say, actually I think I should start when x is 3, because it's the, so when x is 3, so now I come and say this is 2 into 3 plus 3 square root of this minus 3 plus 1. So what is this going to be? This is going to be 6. This is going to be 9 root of 9 minus root of 4. And this is 3 minus 2, which is 1. Then I also come and do right hand side. Right hand side I have x minus 2. What is x? This is 3 minus 2. So this is root of 1, which is 1. So you see left hand side is equals to right hand side. So x is equals to 3 is true. Now I don't know if this space can allow me to do when x is equals to -2. Still do the same thing. You come and say what is left hand side. Left hand side is 2x plus 3 minus x plus 1. So now I say this is 2 into -2 plus 3 minus -2 plus 1. This is still root. So here what will I have? I have -4 plus 3 minus this is -1. So I end up having -1 minus -1. So maybe since this is the same, I can say this is 0. But you can already see this may not be true. Then I come and say right hand side. What's the right hand side? X minus 2. What's our value of x this time? This is -2 minus 2. And this is square root of -4. So you realize that right hand side is not equal to left hand side. So x is not equal to -2. So usually when you, for all these numbers that we are going, the next slide I'm going to show a simple exercise, but for every number that you're going to solve using Surds, solving the equation, like when it's involving Surds, usually you're going to generate a quadratic equation somewhere. You solve that equation, find two values of x, but however you have to prove, because not both those values of x are going to solve that equation. So this process called verification becomes very important. You have to show that you're verifying such that show that only one of your answers is correct for that particular equation. Okay, so now this is the exercise for us to try out. So what we've done is this number 1, but as we've seen, all these numbers are going to use the same pattern. You're going to form a quadratic equation. You solve a quadratic equation, you get two values. After getting those two values, you verify. That's why you see here we have one answer. So you have to verify and see which is the correct answer. So you try out this. Now let's see another concept in Surds.